Today we're continuing with Chapter 4, Section 1. Right triangle trigonometry. Okay? Now, yesterday we learned the 6 trig ratios. Okay? We're going to write those down neatly, if this board will let me. There we go. Sine of A, cosine of A, and I'm going to write tangent of A. Over here, I'm going to write the cosecant of A, the secant of A, and the cotangent of A. In this problem, it says, if the cotangent of A equals 8, find the exact values for the remaining trigonometric functions for acute angle A. So the cotangent of A is equal to the number 8, which represents 8 over 1. Now what I'd like us to do is do a quick little review. You guys probably have seen this many times before. We're just going to utilize it. So represents the relationship of sine, cosine, and TOA tangent. Okay? So what are the relationships of sine? It's the opposite over the hypotenuse. This is the adjacent over the opposite over the hypotenuse. And this is the opposite over the adjacent. Now, if you wanted to, instead of writing opposite and hypotenuse, if you wanted to, you could write O over H. If you wanted to do A over H, that's fine. You have to find a way that works for you. All right? So if you wanted to write just the capital letters to represent what's happening up here, that'll work as well. All I want you guys to do over here is understand that these are the reciprocals. So this would be H over O, H over A. And this one is equal to A over O, which means the adjacent side over the opposite side. Okay? So if you like doing the 3 abbreviation, that's fine. If you just want to do the capital letters, you can do that as well. Just find what works for you. So right now, if this is 8 over 1, automatically you know what tangent's going to be. What's the tangent going to be? 1 over 8. Now listen, that means my opposite side is a 1. My adjacent side is an 8 in relationship to angle A. So here's what I want you guys to do in your journal. You need to draw a picture. So what I'd like you to do is I'd like you guys to draw a picture of this triangle right here. There's multiple ways to draw this right triangle. We're just going to draw it like this. We're going to call this side 1, this side 8. We're going to label this side capital A. Here's the measure of my angle right in here. Draw an arrow labeling my opposite side, which means this is my adjacent side, which means this side must be my hypotenuse. So draw that picture right in. Alright, so what we need now is we need to find this hypotenuse. So here's the formula for the hypotenuse. Now you guys are used to seeing a squared plus b squared equals c squared. Here's the formula for the hypotenuse every single time. You got to do a squared plus b squared, then take the square root. So the formula will always be the square root of whatever the sum of a squared plus b squared is. This is how you can find your hypotenuse every single time. Just plug them in. What is 8 squared, Josiah? And 1 squared is 1. So that's going to be the square root of 65. And we're done. Okay, so C equals the square root of 65. So everywhere you see the hypotenuse, what are you going to write in that slot? You're going to write the square root of 65. So let's do that. Up here, my opposite side was a 1. My hypotenuse is the square root of 65. My adjacent side was 8. My hypotenuse is the square root of 65. Over here, we're just going to do the inverse of the flip of this. This is going to be the square root of 65 over 1, which equals the square root of 65. And this one is the square root of 65 over 8. That is simplified. So right now what I'm going to do is I'm going to box in all of my simplified answers. That's simplified, this is simplified over here. The only numbers that aren't simplified are any fractions that have an irrational number in the denominator. These are not simplified yet. Alright, so right here, this one becomes the square root of 65 over 65, and this becomes 8 radical 65 over 65. Now that really isn't helpful for anybody who doesn't know how to do it. So we're going to do it real quick. Alright, so what do we have? We have 1 over what? 1 over the square root of 65. Now, just remember, this is called an irrational number. If you ever want to have somebody look at you funny, just go to a store and say, "Can I have a square root of 65 bananas?" And the people at Walmart will make you look to them. Well, you look ridiculous. But if you wanted to make this from an irrational number to a rational number, you have to multiply both the numerator and the denominator by whatever's in this radical, and that's how you get a rational number right here. Just remember, the square root of x times the square root of x is just x. If I said what's the square root of 3 times the square root of 3, that's just a 3. Now why is that the case? Because what's the square root of 3 times the square root of 3? That's the square root of 9, because 3 times 3 is 9. But what's the square root of 9? 3. So it's just a fast way of doing it. Okay? Now, here's a shortcut. You do it long enough, you see a pattern. So if I say, what is a divided by the square root of 7? So any number divided by the square root of 7 will always equal a times radical 7 over 7. If I said, what's a divided by radical x? I know what my answer would be. Without doing a whole lot of work, I know it's going to be a times radical x over x. So if you wanted to, you could write this down. Hey, this is how you could do it every single time. And so these are your final answers. The only time you have to simplify it, if these numbers could be, if these fractions could be simplified, you'd have to go one step further. All right, so next problem we're going to do. We're going to go to problem number 7 and zoom in. So right now, in your journal, what I'd like you to do is I'd like you guys to write, find the measure of angle theta. So right now, jot that down in your journal because this is the section on how to find the measure of an angle. We're going to be finding the measure of angle theta, which is this angle right in here. And we're just going to round our answer to the nearest whole degree, because that's what it asks us to do. So right now, jot this down, and we'll get started. All right, Emily, can you predict what I'm going to do next?
We're going to draw a line from the side to the opposite side.
Very good. So we're going to go from theta over here to 2. That's going to leave us, that's going to identify the opposite side. Once I've identified the opposite side, what's the next thing that I do?
Label the adjacent.
No. I always go from the opposite to the hypotenuse. And the adjacent is the most insecure because I always label it last. Okay? I know it's kind of sad. So, label your opposite side, label your hypotenuse, label the adjacent side, make sure. Now, my adjacent side I'm going to call A. My hypotenuse I'm going to call H. And my opposite side I'm going to call O. Right? Now, let's think about the information that we have. We have the what? We have the opposite, right? We have the opposite side. And what else do we have? The hypotenuse. So those are the two that we have. So whenever you guys write, so, ka, toa, you scan this and ask yourself, which one of these am I going to use? I'm going to use the one that has the opposite side and the one that has the hypotenuse.
Oh, wow. So it's the so.
Yeah, so I have to use this one. Okay? So you scan and figure out which one am I going to use. Well, this one I'm going to use so, which means I'm dealing with the sine. So the sine of theta equals my opposite side in relationship to my hypotenuse. So the sine of theta equals, what's the length of my opposite side? 2. What's the length of my hypotenuse? 3. Write this down. You need to know this. That's the first thing you do. You have to set that up just like that. The sine of this measure of this angle equals 2 over 3. That's the first step. Now, once you guys have written that down, something that you are not allowed to do, because the sine always goes with the measure of an angle. Typically, if I said this, if I said 2 times x equals 2 over 3, if that was our problem, okay? Or, even if I said 2 times theta. If I said 2 times theta equals 2 over 3, what would you guys want to do to solve for theta if you had the number 2 in front? Not sine, but 2. What would you do? No, not multiply by 2. You probably would do what? You'd probably take both of those and divide them by 2. Most students would divide both things by 2. However, that's not going to work. It's not going to work because you cannot divide both sides by the concept of sine. Anytime in the calculator, you guys hit the sine button, what happens? It opens up a parentheses, because what are you supposed to put in? You're supposed to put in the measure of an angle. Okay? So if you say the sine of 30, that's going to equal a half. That's going to equal the ratio of 1 over 2. So it equals a ratio. So right now, we can't divide both sides by sine. That's not going to work. So what do we need to do instead of dividing both sides by sine? So, everybody, if I said 2x equals b, and you say, I told you, you're not allowed to divide both sides by 2, you could still multiply both sides by its inverse or its reciprocal. So this is what we're going to do. You need to put the concept that you need to multiply both sides by the inverse of sine, which means 1 over sine. So in order to solve for theta, which is the measure of the angle, what you're going to have to do is this. You're going to have to take the inverse of sine on one side and you're going to have to take the inverse of sine on the other side. These now cancel out. So if you ever want to find the measure of the angle, you have to find the inverse. You have to use the inverse of either sine, cosine, or tangent. Now this will only work if and only if you are also in degree mode. So we're going to go over both of those. Okay? So right here, this will be my answer. Theta will equal the inverse of sine of 2/3. This will be the answer that I'm looking for. So right now I'm going to go to my graphic calculator I'm going to hit the mode button. I'm going to make sure it's not in radian mode. I'm going to go down, make sure it's not in radian mode, make sure it's in degree mode, press enter, then hit second mode. And can you guys see right here? I'm going to zoom in as much as I can, as far as I can zoom in. You guys see sign to the -1 right there? You hit second sign, and you type in 2 divided by 3. And when you press enter, that gives you the measure of your angle. Okay. By the way, what's the fraction of 2/3? What's that approximately equal to? That's equal to that 0.6 repeating, right? It's equal to 0.6 repeating. So if I wanted to prove my answer, I could say the sine of the measure of this angle is equal to 0.6 repeating. So what's the measure of our angle? What is theta equal to? It's equal to 41.8 degrees, but it said rounded to the nearest whole degree, so your answer is 42 degrees. Now, the only time you use the inverse button, right here, when you use it, when you're trying to find the measure of an angle. Do the next one on your own. All right, we've had a request, number 5. All right, here's the request. All right, it says, on a college campus, the library is 80 yards due east from the dormitory. So here's what I did. Okay, I'm going to put a dot on the page. All right, I'm going to call this D for dormitory. And it says the library is 80 yards due east. So what I'm going to do is I'm going to go a certain distance to the library. And I'm going to label that 80 yards. D is the dormitory, L is the library. The library is 80 yards due east of the dormitory. And the recreation center is due north of the library. So due north of the library, I'm going to go up. Okay, so go up. Okay. Put a dot right here. And what am I going to label that as? What do you think? R. Yes, the recreation center. Now, the sidewalk, it says the college is constructing a sidewalk from what? From the dormitory to the recreation center. So what I'm going to do is they are constructing, it's not complete, but they're constructing a sidewalk from the dormitory to the recreation center. All right. Now the sidewalk will be at a 56-degree angle with the current what? With the current sidewalk between the dormitory and the library. Well, where is the dormitory and the library? That's this guy right here. So what's the measure of this guy have to be? 56. And put 56. Guess what I just found? I found my reference. Right here. This is where I'm going from. Going from this angle. Now it says, to the nearest yard, how long will the new sidewalk be? It looks like I am looking for the hypotenuse of this right triangle. And there it is, all set up. Now, if I follow the same pattern that you've seen me do numerous times now, what's the first thing that I'm going to do? Label the opposite side by drawing an arrow across. That's what I always do. I am a creature of habit. So I'm going to label the opposite side. I already did the hypotenuse because I know how to find the hypotenuse of a right triangle. Which means, what does this side have to be? So the first step is to label all of your sides, like name them. Which is the opposite side? Which is the adjacent side? Which is the hypotenuse? Then I'm going to write my 3 basic trig ratios. Then I'm going to ask myself, self, what do I have and what do I need to find? Well, I have theta. What's theta equal to? 56. I have the measure of my adjacent side. What's the measure of my adjacent side equal to? 80 yards. And what am I looking for? I'm looking for my hypotenuse, which is, heck if I know. So, what do I have? I don't have my opposite in hypotenuse, But I do have my, I'm looking for my what? My hypotenuse, and I have my adjacent, so therefore what must I use? Cosine. So I write, the cosine of theta equals my adjacent side in relationship to the hypotenuse. That's what I write here. And then I fill it in with the information that I have so I can solve it. So what information do I have? What is theta? 56. What is my adjacent side? 80. What is my hypotenuse? You can put x, you can put h, whatever you want to do. I'm going to put x right here. And there is your proportion all set up. So let's cross multiply. See what we get. Cross multiply, you get x times the cosine of 56. So we get x times the cosine of 56 equals 80 times 1, which is 80. So a number times the cosine of 56 should equal 80. So we only have one more step to do. Divide both sides by the cosine of 56. And whatever that is equal to, my friends, will be your approximate answer for the length of the side. Alright, here's our last problem. The very last problem we're going to do today is we're going to teach you how to solve a triangle. And when it asks you to solve a triangle, you want to know what that means. When I say solve a triangle, that means find everything. How many sides does it have? 3. How many angles does it have? 3. So listen, this is what you got to do. You got to write. You're going to find the measures of all the angles of the triangle. I'm going to write that in capital letters. And I'm going to write in lowercase letters. You're going to find all the sides of the triangle. So here we go. The angles of the triangle are angle A, angle B, and angle C. A, B, and C. Now the book does a really nice job of writing cool angle symbols. I don't have a very good job of writing awesome angle symbols. So you'll always notice I always put like a little arc right here to help you understand that's an angle, not an L. Okay? So angle A they've given us is 22. Angle C, they've basically given us that too, that's 90. So angle B has to be 68, because all of these have to add up to 180. Angle A and B, something you should know, they will always be complementary. Which does not mean they're going to complement each other, like say, hey, you know, you look really good today. But they add up to 90 degrees. Sides are always lowercase letters. Okay? So lowercase a, lowercase b, lowercase c. Lowercase a is across from capital A, lowercase b is across from capital B, and lowercase c is across from capital C. So here's how you would identify them. There's the capital A, so you put the lowercase a right here. Here's the capital B, you put the lowercase b right here. There's the capital C, so that means our number 14, right there, that's the length of side C. So the lowercase letters are directly across from what? Across from the angle. They go on opposite sides of each other every single time. Then at this point, you have to solve for A and B using trigonometry. You're going to solve for A and B. I'm only going to solve for one because people are about to pass out in my class. We don't want anybody to die from boredom. So we're going to just do one of them. Okay? So what I'm going to do right now is I'm going to draw an arrow going across. I'm going to label this the opposite side. I'll try to do it quickly because people are on life support. All right? So if that's the opposite side, this is my hypotenuse, which means this is my adjacent side. So if I wanted to find my little a right here, and I have my hypotenuse, and I'm looking for my opposite side, lowercase a will equal the sine of 22 degrees, which is equal to a over 14. So when you cross multiply, how did I know how to use sine? Because of 3 basic ratios. I chose sine because I have my opposite side and I have my hypotenuse. So when you cross multiply, you get A equals 14 times the sine of 22, and that will give you an approximate amount for A. You do the same thing for B, except you're probably not going to use sine, you're going to use cosine instead of sine for lowercase b. If you're having problems labeling lowercase a, lowercase b, and lowercase c, write this down as a map, as a guide. Have a good day.